All right, we're about to pull back the curtain on one of the web's most critical, but, almost completely invisible pieces of tech. This is really the secret engine that makes the internet feel fast.
I mean, you've definitely felt this, right? You click on a link to a new site and it feels like it takes forever for all the pictures and text to load in. But then you go back the next day and bam, the whole thing is just there, instantly. So what's actually happening?
It honestly feels a bit like magic, doesn't it? As if your browser just perfectly remembered everything from your last visit. Well, today we're going to peek inside the magician's hat.
And surprise, the secret is not magic at all. It's something called the HTTP cache. This is the unsung hero of web performance, and it's working silently in the background pretty much every single time you're browsing the web.
So what is this invisible engine, really? Let's get into it and break down how it actually works its magic.
Okay, think of it like this. When you visit a website, your browser has to download all of its parts. The logo, the style sheets that give it color, the JavaScript that makes it interactive. Well, the HTTP cache is just a little storage space right there in your browser that keeps a copy of all those parts.
Now here's the really crucial part. This isn't something that a web developer has to manually code into their website. It's all an automatic conversation happening behind the scenes. The website's server gives your browser a set of instructions, and your browser just follows them.
So, if the server and the browser are having a conversation, what does that actually sound like? What kind of instructions is the server sending? Let's listen in.
It's really just a simple four-step dance. First, the server sends a file, but it attaches some special notes called headers. Your browser sees those notes and stores the file. The next time you visit that site, your browser basically calls up the server and asks, "Hey, I've got a copy of your logo from last week. Is that still the right one?" And the server gives a simple yes or no answer.
And how does it communicate all this? Well, it uses these headers. Cache control is the big boss. It sets the main rules, like, hey, you can hang on to this file for an hour. Then you've got things like etag and last modified, which are basically like a version number or a timestamp on the file. They let the browser be super specific when it asks if its copy is still fresh. And this is the key. If the server looks at the version number and sees that nothing has changed, it doesn't send the whole file all over again. No way. It just sends back this tiny, super efficient little message, a 304 not modified. That little packet of data saves a massive amount of download time. And that's the magic behind that instant reload.
All right, let's talk about the one part of this whole thing that confuses pretty much everyone, even seasoned developers. Get ready, because here comes the plot twist. So let's say you have a file. Maybe it's a news headline or stock prices. You want your browser to store it to be fast, but you always want to double check with the server to make sure you have the absolute latest version before you show it to the user. How would you tell the browser to do that?
Logically, you'd think the answer is a setting called no cache, right? Makes perfect sense. But as our source material puts it so well, the name no cache is incredibly misleading.
And this slide shows you exactly why. No cache does not mean do not cache this file. It actually means go ahead and cache the file, but you absolutely must check back with the server every single time before you're allowed to use your cached copy. It forces that recheck to guarantee the file is always fresh.
Now, if you have something you truly never, ever want saved to the hard drive, we're talking sensitive banking info or personal data, the correct instruction for that is no store. That one actually means what it sounds like. Do not store this file, period. Okay, so we've established that the HTTP cache is this awesome automatic server-driven system, but it's not the only kind of cache in the browser. Let's see how it stacks up against its more hands-on sibling.
All right, for situations where you need way more granular control, developers can actually turn to something else called the Cache API. And this one is not automatic at all. It's fully manual, fully programmable with code.
And this comparison really makes the difference crystal clear. The HTTP cache, it's controlled by the server with those headers, and it's totally invisible to the website's code. It's perfect for just general speed boosts. But the Cache API is controlled with JavaScript code. It's totally visible, and it's the tool you need to build really advanced features, like making an entire website work when you're completely offline.
So, after going through all of that, the automatic system, the confusing names, the manual options, what's the one thing you absolutely have to remember about all this?
Here it is. The HTTP cache is your foundation. It's the simplest, most automatic performance win you can possibly get. Just by setting up the right server headers, you get a massive speed boost basically for free. It is your first and maybe your most important line of defense against a slow website.
The web is just packed with these powerful, invisible systems working behind the scenes to make everything go. We just looked at one of them. So what hidden engine should we dive into and explain next?